So thanks very much for joining us today. We're very privileged that Vinny had asked Veronica and I to really duplicate what we did recently at the Ontario Association of Architects AGM. We had probably about 140, 150 people in our session. It was really nice to actually be in front of a live audience. We'll do our best to keep our energy levels high. And hopefully, as Vinny said, if you do have some questions, we've been known to really sort of dive into the material. And if there is questions still at the end, which we haven't got to, we will reach out with answers for you. So next, please, Veronica. So what we'll be discussing today is the Ontario led initiative, but this is goes right across the country with the exploring in detail through work and opportunities, etc., that we both had in the sector, and that was really the cause for us to develop the mid-rise guide. It was around detailing the opportunities that come from the code provisions across the country, and we've hopefully illustrated in a really positive way how we need to go forward in the future using wood in our future environments and our buildings, etc. So hopefully you enjoy it. Next, please. Some of the learning opportunities that we'll cover today, really it's about the overview of the mid-rise code provisions, and really Veronica's going to start to dive into the environmental, economic, social and cultural benefits of using wood in building design. We're going to hopefully clearly illustrate design opportunities presented by the mid-rise requirements, and it really giving you an idea of how to establish a good business case for it. And then we'll show you how the key design and planning considerations made right at the beginning will optimize wood in your designs. Next. So here's a cover of the Canadian Mid-Rise Construction Guide. Next. And we'd like to say a big thank you for the FedNor program and Natural Resources Canada for seeing how important this particular guide was. We were obviously something like this and this scale, we couldn't have done it alone. So Veronica and myself drew from the expertise of several key people that were involved in the different sections within the guide. And a big thanks to the CECO-BOIS program that provided section 5, which is the technical guide. There was a French guide which was produced some 6 or 7 years ago, which we used as the basis for the code development work that we did. Next. So big question, why the mid-rise guide? Next. So the ensuing publication, which we drew all the research from, and actually when we started to pen it ourselves, were really to concentrate on the code opportunities that the provisions across the country had left us with. It's been active for at least 12 years. The first province to adapt to 6-story wood construction was British Columbia. And each of the provinces across the country were at different acceptances and understanding of what those code provisions gave us. So really what we had done in the Woodworks program some 4 years ago was we did a series of focus groups right across the country and gathered from those particular focus groups, a lot of research about where each of the provinces were in their adoption of wood construction. So various degrees of optimization we really saw, what things were hindering the progress, the understanding of the code provisions, etc. And from that, we then laid out a way forward, working together about how architects look at building design. And I think that was the part that really we hadn't explored well enough in laying out really the process of adopting 6-story wood provisions and understanding really what the code allowed you to do with them moving forward. We then have seen over the last 5 or 6 years really how the industrialized processes have started to come through, how prefabrications being used by project teams. How do you get to that? How do you understand what's available, etc.? So this is all contained within the mid-rise guide. Next, please.
So our strategies for building design over the coming years will have a critical impact on whether we can achieve climate stability, whether we can form stronger communities, and whether we can move towards an architecture that positively impacts our cultures and our social networks to create healthy and thriving communities. You know, and as we know, buildings are have multifaceted impacts on the environment, the social, the economic, and also cultural systems. You know, thinking about mass timber and thinking about prefabricated systems, there are many kind of opportunities that impact each of these four sectors. We can consider resiliency and conservation in our buildings by reducing carbon. We can provide healthier communities that are dignified and equitable, but we can also develop new skills and employment opportunities and foster new industries to all really support thriving communities. So we come back to the environmental impacts, because I think this is where, you know, the increased use of mass timber and prefabricated systems can really have a great impact. And so, like many places around the world, Canada is seeing the direct impact of climate change. This is an image of the NASA Earth Observatory taken June of 2021, when British Columbia had this heat dome that covered the province, and it resulted in record-breaking temperatures and significant forest fires that summer. And the impacts of climate change are presenting significant economic strain on our systems as a whole. The fires in British Columbia in 2021 resulted in over $881 million of damages and impacted over 4,000 homes. Months later, the extreme rainfall and flooding that was caused in British Columbia, mostly because of the soil that was unstable because of the forest fires, resulted in over 15,000 people to evacuate their homes. And it impacted critical food sources, resulting in over $450 million of insured damages. And we saw weeks later that the maritime provinces had also extreme rainfall that same year. Now, climate change is impacting our ecological systems as well, which is linked to the decline of biodiversity and pollinator animals. Biodiversity is critical in safeguarding global food security and underpinning healthy and nutritious diets in communities, and also improving rural livelihoods and resiliency of people and communities. A dramatic die-off of pollinator animals, which climate change is one of the key factors in their die-off, could result in the loss of essential crops of over $500 billion a year. So the economic impact of climate change, along with the social, economic, and cultural impacts are great, and we must really be considering differences in how we proceed forward. Now, on a related concern, the United Nations reported that the world's population is expected to increase by 20% from now until 2050. And by the turn of the century, it's expected to double. Now, new building construction, densifying existing housing stock, and retrofitting existing buildings will have a significant impact on how carbon is produced and carbon produced by materials and how it's released into the environment. And many world organizations are stressing that we must achieve net zero carbon well ahead of 2050. We must accelerate it 2040, and if not sooner. You know, we're seeing this in our own kind of cities and towns in Canada as well. The Toronto City Council has just passed regulations to change its 2050 targets to 2040. By 2030, there's an urgency to develop net zero carbon standards. And also, you can see here from this chart, the kind of stepped system where it's actually saying here that new buildings should achieve net zero carbon as of today in terms of its operation, 40% reduction in embodied carbon. And this is where mass timber can play a significant role. And by 2040, we are zero on every kind of aspect, including existing buildings. Now, an emerging area study is embodied carbon and its impact, because embodied carbon locks carbon into place as soon as the building is built. There's no way to really improve that condition once the building is built. And that's why materials becomes a significant component of that. This was a study that I undertook with some colleagues at Athabasca University, where we studied the impact of carbon on both a code compliant building and a net zero carbon building. So we did a typical 5-story mid-rise office building, and we ran metrics for a code compliant, thinking about operational embodied carbon, and also one net zero. What was interesting about the summaries that we concluded was that by simply changing certain things, like the way that we looked at our operational systems and moved towards a more passive design systems, we were able to reduce 48% of the operational carbon. Now, by simply switching the concrete reinforced structure, which you see typical in these types of buildings, to a mass timber structure, we were able to receive a 83% savings on embodied carbon. To me, that's very significant, because simple moves in considering our materials and in particular our structural systems can have significant impact on embodied carbon. You know, as well, many planning and urban strategists are speaking of the importance of the missing middle. You know, this is the community-driven, community of mixed use, mid-rise buildings that encourage livable and thriving cities. And at the same time, Canada, as many parts around the world, are faced with a housing crisis. Almost 1/3 of Canadian households live in inadequate or unaffordable and unsuitable houses. Most vulnerable are women, youth, and visible minorities, as well as Indigenous communities. So the opportunities for mass timber and prefabrication to bring healthy, equitable, and durable housings into these communities is great, and we must look towards those systems as well. Now, there's strategic plans across the country that are really looking towards developing northern communities, and as well as densifying existing main streets. And this is something Stephen talked a lot about when we were starting off the guide, is the potential of mass timber to build on top of these existing 2- to 3-story buildings, which we see across the country in many towns across the country. And the reason that it becomes very fruitful is that mass timber is a very light system that could easily be placed on top and have minimal impact on existing buildings, not only keeping the existing housing stock, building stock, which reduces embodied carbon in itself, but also preserving the heritage of our cities and towns.
So I love this slide because you can see Toronto in the background there in the top left, but you can see how low we've been building. Trees are higher than the buildings themselves. This is an illustration. This is the Our House project on Queen Street East that was completed late last year, and is now fully occupied. But they used a prefabricated mass timber system in this case, on an incredibly busy street. This is Queen Street East. You can see it there in the foreground. It's a main commuter line. It has streetcars, etc. So the development had to be in a way that there was no impact on the streetscape. They couldn't shut down the main street there and actually build from the front of Queen Street. It was all fed from the back. So prefabrication and the systems involved were deemed to be the way to do this. So it was just in time delivered. Once the foundation work was in place, then it was craned in with a mobile crane from the rear laneway and erected up to the frontage. They started from the front of the building to the back. But it's a positive impact on the street. It stays within a height which is allowable. And also has less impact. And again, back to Veronica's point about the existing building stock, you could see those 2-3-story buildings that are surrounding the whole development here, which really would lend themselves to actually building on top. Obviously foundation analysis would have to play. But the idea is that you can change the cityscape without having a lot of impact on it by using the existing stock. So just something to think about. Next, please. So in my career, I've had the privilege of going around many different countries in the world looking at mid-rise development. I love this this is a development that was done in Sweden. This was built, several of mid-rise buildings were built around the main transit system within Stockholm. Very limited parking. The whole drive for this was to be a transit-friendly community, walkable community, etc. And these were little nodes of buildings that were placed in place, developing a community feel, having lots of family units, so two, three unit communities to encourage families rather than having a studio apartment, which really you're looking at one or two people in them. I love this because the cladding on these particular buildings is actually Western red cedar. So going to Sweden and seeing Canadian products actually being used in an application that we can't actually do here was quite ironic. But the idea was these buildings were a mix of incomes as well. So there was affordable housing units as well as privately owned. So it's just something to think about how planners can create these great little nodes of community. Next, please. So some more illustrations of what the Swedes have done very well. They took a brownfield part of Stockholm around the seaport district, and actually they went into this in a big scale. They want to get families back into the city centre, and you do that by encouraging really good, healthy, quality housing. And what I liked as well was the on the flip side of this, at the back of the buildings, there was community gardens, allotments where people were encouraged to grow their own food, but also on the street side of the development as well. They had these lovely gardens which people were encouraged to sit there 12 months a year. They play hockey and ball and everything that we do here, and very narrow streets. They wanted to discourage as much street parking and automobile use as they possibly could. And they had a very narrow street, which is just 2 lanes. And I remember the comment coming back that from the Canadian delegation that I was with, that they'd never get their fire trucks down here in Canada. And then the architect and planners that were taking us around the development looked at us and said, well, just tell them to get smaller fire trucks, which I thought was quite, it's a comment that's always actually stuck in my brain. So the next. So we're going to take you really about where the work started for Veronica and I when we got given the privilege of doing this guide, about how project planning can be used to optimize the design of these buildings using the code opportunities. Next. So I call this Veronica's brain, with Stephen pushing and prodding. It just turns out that we're both big post-it note fans. Our walls around our offices are covered in post-it notes, but this was a really good way of me unlocking how an architect starts to think and needs to think about working with their clients to actually get the kind of building which they see as their vision and an architect can help them achieve. So it goes through some of the pre-planning considerations, understanding the code provisions. The key part of this is, how am I going to do this with the structure? Is it going to be an all wood structure? Is there going to be a hybrid structure? Is it going to be a podium, etc.? And some of the considerations and the site specific considerations an architect will go through mentally. And I think this was really my eureka moment when I started to understand the sequencing that goes through an architect working with a client and how they actually arrive at a decision on how the building and what kind of materials are going to be in the building form. Next. Veronica, do you want to take this one?
Sure. I think, one of the things we talked a lot about as well and understood through experience is that we really can't do this alone. As architects, as owners, as developers, we really need to come together as an integrated team and really work upon each other's strengths and experiences to, bring innovation in architecture. So when we're thinking about the integrated team, we need to start thinking about this right at the planning stages. You know, ideally, this would be integrated into the client's RFP process so that consultants can respond to it integratively. Having builders, constructors, prefabricators of mass timber at the table can really lead to the efficiency of the system and also the economic of the system. So, you know, architects can speak to the program and planning of needs of the building. The structural engineers will talk about efficient bay sizes and thinking about that really early on to maximize the efficiency of mass timber in relationship to the program that needs to be designed to. The mechanical engineer and the electrical engineers on board early so that there's an early integration of systems, because in mass timber, everything is prefabricated right down to every penetration in every floor slab. And so you really want to have an enhanced integration of systems. There's no coring through that slab when you're on site, or ideally there isn't. And also, you know, fabricators will bring their own knowledge in terms of efficiencies of their products, and also sequencing of construction, which will lead into, you know, an overall, you know, just more enhanced and more efficient design.
So this was a project that was done in Muskoka a few years ago. $60 million lakeside lodge, 150 units, 1, 2, and 3 bedroom models. Very large building, 155,000 square foot, 5 stories in height. But some of the considerations, getting back to the previous slide, was really understanding the process and how it was going to be built, because this actually straddled 2 full winters. So that was a big driver on what kind of prefabricated system the builder was going to look towards using. The plan was to do a lot of the foundation service work through the first fall and into the winter, and then delivery of the factory built wall panels, light flame roof truss systems, etc., were then brought in the spring, and then the erection started through the summer into the fall, and then they wanted to get the building as closed in as possible for all the service work to continue when the building was watertight. Now, this was a challenge, just not just because of the size of the building and the 2 full winters, but it was also in an area where maybe there was a skilled trade shortage. So that was another big factor. The constructability and the approach to the construction was needed very early on. How are we going to do this when maybe the trades aren't available? So all part of the things that you need to be thinking about moving ahead. Next. Just some illustrations on the time repetitive nature of a building this size. It really does lend itself to repetitious work inside a factory, so that when the panels actually arrive on site, the floor slabs, etc. In this case, it was an I-joist system. The erection process and sequencing becomes very important too, that you know how you're building it, all the way up to the firewalls, etc., going up to the full top story, putting the roof slabs on, and then moving along to the next part of the build. Next. So the approach as well, when we were talking in our research, was like, you have to know your product chain and supply chain, where the products are going to come from, making sure that you can be as local as possible. And if you are bringing product from far away, in this case our product and supply chain slide shows mass timber, but this is very highly important and a really critical path, because if what we've seen in the last 3 or 4 years with the amount of building and the amount of supply issues that we've potentially had since COVID, hopefully we're through the worst of it now. But it's very important to get yourself in line, knowing if there is a 12-month wait, which, you know, sounds like a lot, but if you're into sort of site plan approval, zoning amendments and stuff like that, you can get yourself in line, ready to supply when the time comes for the build. A light frame is something you need to consider as well. Most of the I-joist and engineered wood and dimensional number companies that typically supply 2, 3, 4 story buildings they had issues around supply as well. Not as much as 12 months, but you need to get yourself in line and actually know where your products are coming from. And this is where Vinny and the program and the Maritimes can really help. They understand local supply chains, trust associations, etc. So maybe a call, maybe a better understanding on what's available locally is a key thing that you need to be doing very early on in the project development. Next. So the code provisions. Next slide, please. What we did, because this went from a strictly an Ontario guide to a national guide, we wanted to illustrate very comprehensively. There's 14 pages of Group C residential and Group D business and occupant and building business space, etc. So we did these very comprehensive code matrices. So wherever you are in the country, whatever code provisions, whether it's the 2012 OBC or it's the Quebec Building Code or the 2020 National Building Code, or in the Maritimes, maybe the 2015 National Building Code, you'll be able to find the column and go down, and it tells you exactly what you're allowed to do, sizes, areas, fire rate resistance ratings required for your mid-rise wood buildings. We cover the building area, sprinkler requirements, for fire resistance ratings, non-combustible requirements if there are any in your buildings, height restrictions, mixed major occupancies and separation requirements, cladding requirements, emergency power supply, and any of the Part 4 building code requirements around structural and seismic requirements, and any of the fire code requirements that are required in your jurisdiction. Next. So going a little bit closer to home and talking about what I've just said, we've illustrated exactly what the requirements are. In this case, the National Building Code 2015. So you're able to see that residential occupancy, for example, for 6 stories to be 1,500 square meters. And it is interesting to note that if you flip over to business and personal services, 6-story, you can do 3,000 square meters, for doubling of what the residential allows you to do for business and personal spaces. So this is really interesting, and especially when you start to mix up code provisions and the assembly requirements when you're bringing in other mixed major occupancies into the mix. So what we try to do is illustrate the opportunities for different types of buildings depending on where it's being built inside the city. Next. And some illustrations here, which are included in the mid-rise guide about those types of areas. In this case, this is the 2012 OBC, which we use on a day-to-day basis, 3.2.2.43a. Unfortunately, the numbering changes depending on where you are and what code you're using, but hopefully those matrices make it very, very clear, and we've illustrated nicely exactly what type of buildings are allowed. Next. Again, this is for the business and personal space areas. Next. And we've tried to illustrate as well comprehensively height requirements within the code and what they're allowed to. So 6-story building allows you to be 18 meters. So that's from the floor level up to the level of the floor on the 6th story. We've seen a lot of this being used in Ontario, and we've seen a lot of 5-story buildings because of the extra ceiling heights that may be required or maybe part of the design process, again, that Veronica would be involved with. Next. Do you want to talk about this, Veronica?
Sure, thanks, Stephen. One of the things that we really wanted to stress in this guide is that, there was this kind of preconception in the industry that the mid-rise was only for Group C and Group D residential and personal business use. But, really the guide actually, the code requirements and the changes in the code allow for a lot of mixed use developments. And this is something that's really interesting because we're seeing it in different cities and towns across Canada, the integrated occupancy types. So we're seeing schools integrated with residential mixed use buildings. We're seeing commercial, office, and residential all together where people can live and work in the same building. And so what we've illustrated in the guide was the different opportunities that are involved, and also the specific requirements that are needed in order to mix the occupancies so that you can consider a daycare, a school, or commercial use on top of residential. Even storage and garage uses above grade are possible as well. So what we tried to do in these diagrams is illustrate that chart that Stephen had showed earlier in a visual way, because like many architects, we'd like to see pictures and then we go back into the chart and kind of dig into the information. So here we kind of grouped and we tried to also capture every code across Canada so that you can kind of find your relevant code and see what your specific requirements are. And then you can dig deeper into the code knowing what your starting point is. These diagrams are starting to show, very specific things like, fire ratings and fire separations between the major occupancies. And really it's about kind of coming back to that initial discussion about, thriving communities, about the missing middle, and how the mid-rise requirements and allowing for wood construction in that can start to really enhance that through the mixed occupancies and understanding the requirements of the code by that as well.
This is an interesting project. This was the first development that was issued under the new code provisions in Ontario back in 2015. So the permit was issued, and this was for Templar Flats in Hamilton. So this is on King William Street. Highly historical part of the core of Hamilton. It was a derelict site where the new build is placed there in the center, but the two buildings either side had foundation issues because of the fire damage that was caused when the building burned several years ago. So part of the process was shoring up the existing buildings before obviously the new build could take place. So this was a really interesting way of sort of saying, well, without destroying the actual visual of the area, obviously putting a new building back where there was a derelict space was a key part, but you wouldn't want to sort of like change the landscape too much by saying, well, we're just going to take the 3 or 4 buildings out and then just put something that doesn't exist or has no place in being there in the architectural sort of value of this complete part of the Hamilton core. So they did a fantastic job at illustrating how you could use these new code provisions in a very culturally and historic heritage sensitive area and actually optimize them. So they did a 1-story concrete podium, which obviously went down quite a way with all the shoring work that needed on the foundation. And they were able to link the 2 buildings either side to it. And the podium supports the wood portion. There's a steel moment frame in there, and there's a non-combustible concrete block core, which then provided the lateral resistance for the entire building. On the streetscape itself, there was restaurant space, and then there was an office space as well on that, and then they had residential above. So we have a really good case study on this. It was a joy to actually work with structural engineers, Bordenelli on this one. But also you can see from the cover of the case study down there that the 2 top stories were given sort of a contemporary feel. So you've got the heritage value of the building as it fits into the streetscape, which was really nice. But then also you see the glazing above where you've got that new type of building above. So I did a wonderful job at keeping the streetscape and heritage value of the building. Next. So also illustration, and again, with our code not being completely harmonized across the country, there are non-combustible requirements in some of the code provisions. I don't think in the maritime provinces you have this, but certainly in Ontario and Quebec, we have to have a 1.5 hour fire rating and non-combustible exit stair enclosure provisions as well, which are difficult to navigate, but not insurmountable. And you have to understand how the building's going to behave, because you have a very ductile system with the wood. And then you have a static core that doesn't move quite the same way. So detailing is critically important. We cover this extensively in section 5 of the guide, in the structural section, about making sure that you've detailed the plans properly. You understand the vertical movement inside the building so that the detailing is done correctly. Next. And you want to speak to this, Veronica, about the cladding? And
sure. You know, just as the combustible stair cores and exiting strategies, the code also varies across the country in terms of the percentage of combustible cladding. And in fact, most of the cladding systems needs to be non-combustible when it comes to mid-rise wood construction, but there are some variations in terms of slight percentages to allow for articulation of the facade to have some combustibility. So these diagrams are illustrating that. In Ontario, we are allowed 100% non-combustible cladding, but there are components across the country that allow, 90% and a little bit above that to allow for articulation if you wanted to add a little bit of wood articulation in the exterior as well. And this diagram is just showing some more kind of specifics in terms of the height requirements. You're allowed the maximum 6 stories. The 18 meters is to the, if you have a mezzanine within that 6-story, your 18-meter lands to the mezzanine floor, not the 6th floor. With an overall height of 25, but there's also considerations in terms of grade changes and fire route access. So you can see in the image on the right that if you have 6 stories, you have a little bit of a dropped ground floor, 20 meters maximum to the top of that floor. So there's some specifics in terms of height, which is important to consider because as you're looking at wood structures and the depth of the structures, if you're going mass timber or not, that might be your determining factor, whether you can go 6 stories or you might have to go down to 5. So be cautious of height in overall story relationships. And as well, this diagram also just is illustrating some changes across the country to adopt to different urban environments. So the Vancouver and Ontario Building Code have allowed for a reduced minimum building perimeter facing the street. Mostly because of many of the narrow lots that we see here in Toronto and in Vancouver. So we actually wouldn't be able to do many of the buildings mid-rise if we had to maintain the 25% face exposure. So there's slight differences there.
And this was important as well for that Templar Flats project as well, because it was a narrow abutting site as well. So this was really one of the reasons why the code provisions were written with that 10% rule, because it was the infill. And I'm sure, maybe urban centers in the Maritimes provinces as well, you've got these very skinny sites, which obviously are derelict and you want to put something on them. So this then allows that to happen. So,
do you want me to? Oh, go ahead, Stephen.
Yeah, go ahead. I was just going to say, now we're going to start to review maybe some of the strategies for project planning to optimize the design work. So go ahead, Veronica, you can take it over now.
Sure. Thanks, Stephen. So in the guide, we've kind of identified various types of systems that you can use, both light framed wood construction as well as mass timber. And we categorize them into 3 categories. So framed systems, panelized systems, and hybrid systems, meaning some components of steel or concrete to maximize spans and different considerations in the structure. So within the guide in itself, you're going to see a number of these diagrams that show you a simplified version of the structural system. And then on the left-hand side of the diagram, it's going to have a color-coded kind of key chart for you to think to look at some of the key aspects. We talk a little bit about is it an economic system, is it what are some of the advantages of that particular system, Then that kind of lighter orange box shows you some rules of thumbs in terms of spans and depths of the structure in itself. Again, this doesn't take the place of having a qualified structural engineer, but what it does is just gives you a bit of a rule of thumb so you can start your schematic planning, thinking about the depths of your structural system in the spans. And then in the orange, the darker orange box at the bottom, we kind of highlighted some key considerations for each of the systems, thinking about, you know, specifically the acoustical or the fire rated or the mechanical, you know, differences that you need to consider in each of the systems. So this first diagram just showing us a lightweight wood frame system and kind of walking you through some of the typical spans and depths for that. Stephen, do you want to talk about this project?
Yeah, and you know, and seeing the scale potentially, I always like to illustrate the fact that we're talking about very large buildings in some cases. There's a lot going on. You can see in the foreground there on the site. You need to be considering, you know, site security. Where are you going to put the prefabricated panels? Where's the storage area? These might all be into play around the insurance caveats that you're going to have to think about when you're planning and actually executing a project of this scale. Safety fencing might be a requirement actually in the insurance policies, and it should be. How are you going to manage, you know, people going onto the site when they shouldn't be there, some kind of site security, etc. When they come on, the trades come onto the site. But also the fact that the obviously expedited building is obviously the key to the success of this. You want to get the occupants in as early as possible, and this is big for developers to think about. You know, I've got carrying costs for financial, etc. I want to get that building occupied, so the money's flowing. So big considerations. This was done actually in a prefab wall fashion, and they actually prefabricated the floor systems as well. Probably 8 to 10 feet for the floor slabs, about 30 feet, 40 feet long. So you can imagine, you know, 400 square feet per crane pick to put the floors down. And then they were just followed by the tower crane itself, moving around and actually putting the prefabricated walls. So the builder was very well versed in this type of execution of a project, and that's key as well, making sure that you had qualified trades to actually execute the building in the expedited manner. You don't want someone there scratching their head, going, well, how do I put this thing together? So it's all, again, about the constructability being part of the very early discussions with the client and the architect and structural engineer. How am I actually going to build this building? So critically important when you're moving ahead. Next. And taking the scenario, these are some illustrations of some projects from British Columbia around Westbrook Village, which is quite very close to the UBC campus. This came from nothing. This was like a flat, very large site. But the idea, again, getting back to that very early slides around the Swedish development, it was sort of saying, well, this is what we're going to earmark as being a walkable, livable community feel using mid-rise buildings in a shape and form. And all of these buildings were done using lightwood framing technologies, panelized walls, floor systems, be it I-joist or dimensional lumber. But it all came together, and again, it became an exercise in making sure the project schedules sort of married with the land development, etc., as it went along. So a very good illustration of what can be done with the right will. Next. And, you know, don't forget about the community space as well. It's not just all about buildings. So again, this was to encourage families and the community part of the planning process, making sure you had sort of park space where people could go and relax, lay on the grass, etc. And they, you know, obviously climate dictates with the water features. Maybe we wouldn't have such a luxury in Ontario, but the idea was that they've created these lovely spaces that people can look out on. And it's a wonderful feeling if you do get a chance to walk around in there. Next. And taking this further, getting into some mixed use occupancy buildings. These have commercial space, retail space, shops, restaurants, gallery space, etc. On the street level, concrete podium with the wood above. So you really, again, the illustration of those code provisions and what you're allowed to do are really important when you start to plan out these types of subdivisions and community spaces. Next.
In the guide, we start to look at different kinds of systems in terms of mixing light frame wood construction as well as with mass timber to take advantage of each of the systems. And so this particular system was quite interesting to me, where you have a CLT mass timber floor system supported by load-bearing lightweight wood framing systems. And it's a great way to kind of incorporate prefabrication of both the lightweight system as well as the mass timber coming to site, and taking advantage of some of the longer spans that the cross-laminated timber will give you in terms of the floor spanning. So here's a project where it's illustrating how the load-bearing walls are kind of being built. And also many of those would have been prefabricated and kind of lifted into place. And then the cross-laminated timber floor slab is brought into place with, you know, the way that the crane actually attaches to the cross-laminated timber and is placed down. And so all of a sudden there's an acceleration of the construction.
What's interesting? Yeah, just what's interesting on that previous slide, if you could go back, Veronica, is you can see the holes there as well. So again, the mechanical system integration and the planning very early in the process allowed the fabrication of those mass timber floor slabs, for example, to come with the holes already drilled out for the service work that proceeds following the installation of the floor slab. So it was just an incredibly quick way to expedite the building. I can't say that enough. We've had many illustrations of this approach in building mid-rise. If you can think about it, you know, if you've got a sort of an 8-foot wide slab by 40 feet long, you can imagine how many crane picks that is to actually put a floor deck on. It greatly reduces the amount of crane work and expedites the platform framing part of this to get up and start to build or install the prefabricated walls. So again, there are ways to really expedite that, and we hope we've illustrated that very clearly inside the guide. Next. And, you know, you can see here the scale of the build. This isn't a particularly easy building as well with the angles, and you can see the size and the scope of this. But again, this is a great illustration of the just-in-time delivery. The trucks roll up, they unhitch, they take the trailer back that's been unloaded to the plant. The new on the lower right corner there is the truck with the next panels for the floor slabs. I'm assuming they will go on to the back there where the framing's already done. So you can see again, scheduling is critically important to make sure you're expediting the build process. Next.
In the guide, we also illustrate a number of mass timber systems. And what was interesting to me is when we started the guide, I reached out to Robert Jackson from FASCNEP, and we talked a little bit about the economics of the system and the grid. And really it was about maximizing the efficiency of the wood structure. And what he found in his experience is that a 9 meter by 9 meter mass timber structural grid is a very economic and efficient system. However, some of the challenges that you're going to be faced is that it's going to have a very deep structural depth to the members, to the beam members. And so, you know, when you're considering your structure in terms of economics and, you know, spans, again, as I mentioned before, you want to kind of be careful in terms of your depth structures right up front, because there might be a possibility where you're not going to be able to get 6 stories in the 18 meters if you're using a very deep structural system, depending on your floor-to-floor heights. So in each, as I mentioned, in each of these diagrams, we talk a little bit about the advantages and disadvantages. This one here is a really kind of interesting system. It's being used in a lot of office building designs. But some of the key considerations as well is that with the deep kind of purlin and grid system, you need to kind of have a strategy for running your mechanical system. And so what we're seeing a lot with these types of structure is underfloor, raised floor access, mechanical distribution to avoid running the mechanical system above. in each of the examples or sketches that we provide, we show an example of the building as well. So this is the system that's being used for the Ontario Secondary School Teachers Federation, which is currently under construction in Toronto, Ontario. And also it's, I believe it's a system being used for a number of headquarters for Walmart in, I think it's the west southern states, so the west northern states of the US. But you can see here that in this particular example, the raised floor access system is going to take the mechanical distribution because of the large kind of members that you're faced with here above. And so you also need to consider overhead running of sprinkler lines and lighting as well.
I think that was good, Veronica, when we were chatting about that one as well, about how you need to have that decision made quite early about the structural system, because it's the aesthetics as well, that particular system is actually creating the space inside the structure. And from an architect's point of view, you don't want ductwork kind of looping underneath the beams to take away from the magnificence of the structural system that's being used there. So again, that discussion very early on about the raised floor, running the mechanicals through that was really important in the success of this.
Yeah, and you know, in addition to that, it's also the electrical systems, because you know, often the wood structure wants to be exposed because it can be, and so thinking about how are you going to run your electrical systems? Are you going to have surface mounted conduit everywhere, or are you going to kind of think of another way of running that and your lighting conduit to your location? So all of these systems need to kind of be talked about in that kind of initial meetings with your consultants to make that best decision.
Yeah.
This one here is an interesting system. It's a 9 meter by 6 meters. So what it does is it has very deep kind of girders on the side of the bay, but it has one side open so that you can run your mechanical systems overhead, and you're spanning across laminated timber floor deck from, you know, girder to girder. And so we're seeing a lot of this also in office buildings. The 80 Atlantic building that just won a Governor's General's Award and was recently completed in Toronto uses this system. You can see in the picture on the left that the sprinkler lines are coming in through that open area. It does have a raised floor access system, so most of the mechanical is coming from the floor, but it does allow for easier kind of run of spanning. And this building in itself used a nail laminated timber deck to span from beam to beam. This one here is a 3x4 grid. You might see this a lot in kind of more density residential projects. It was a similar system used to the Brock Commons Tall Wood House student residence. This one here, you have your glue lamp posts and then a cross laminated timber deck that spans directly point loaded on the column. And so you're going to get smaller modules, 3x4, but again, it might be very appropriate for student residence type buildings. Brock Commons was an 18-story building, so it was in the tall category, one of the tallest buildings in the world for a long time. And so it did move into the encapsulated mass timber kind of stream. This is during construction, but afterwards the mass timber was encapsulated. But you can see it's point loaded. And you can also see again here what Stephen had mentioned is that all the mechanical components are being coordinated and pre-drilled and prepped in the slabs beforehand. Now, you know, thinking about you know, things that are happening in the industry, this is where Stephen and I see a lot of movement in the next couple of years is the hybrid systems, thinking about using mass timber and thinking about some of the efficiencies that can be gained by perhaps coupling it with some concrete or steel. So in this system, it's using you know, thin wood composite, concrete composite on top of the cross-laminated timber to help with some of the shear forces that the wood is going to be exposed to when you're trying to go very long spans and have a very shallow structure. This, you know, system you might see kind of implemented in urban areas where you got maximum heights and, you know, density issues that you want to kind of maximize on. And this is the system that was used at the Arbor, which is now called Limberlost Place at George Brown College, where the composite concrete slab was placed simply on top of where the CLT slab bands, which are the beams that come across, in order to give them that little bit of extra shear support so that the fibers of the wood don't kind of split apart. Everywhere else, a thinner concrete topping was applied for acoustic purposes. And that's another kind of consideration, is what are your acoustic ratings from floor to floor, and how are your systems going to be accommodating that? Because wood is a light system, so it vibrates sound more easily. So you want to account for that early on in your detailing.
Yep, good point. I saw a question come in about that.
Yeah. And there's some really great products, and also there's been a lot of research done in this area to mitigate those vibration and sound transmission considerations. This one also was a very interesting system using a steel delta beam, which is a proprietary beam, but you can think of it, you can think of any kind of steel beam coming across, where you then place a cross-laminated timber or even nail laminated timber deck across, and a thin concrete slab above. And this was the system implemented for the design of 77 Wade. And it was, Stephen, did you want to talk a little bit about this?
Yeah, this was one of the projects that's actually been put on hold for various reasons through COVID and office space, etc. But this does have permits granted, and hopefully it'll get going soon. But the idea here was to maximize that 9 meter by 9 meter grid that the client wanted. They didn't want bulkheads. They didn't want the beam scenario, which Veronica illustrated a little bit earlier. They wanted actually a flat ceiling design, so the incorporation of a delta beam, which then supported a nailed laminated timber deck. So this is going to be a spectacular building once it time's right and everything aligns, that it'll get going. So next, please. So in the permit process, and again, getting very back to the very early slide about the illustrated sort of the value of the correct team and the outreach, the authorities having jurisdiction sometimes need to be around the table. They need to understand what potentially you're trying to do, how are you accommodating the fire ratings requirements, etc. This blew through the mid-rise provisions of the building code. We were into alternative solutions for this particular project because it was 8 stories. But then it's a question of having those initial meetings with the city, with the client, with the architect, structural engineer, the fire code consultant, etc., and saying, well, this is how we're going to achieve that fire rating. This is the system that we want to use. So I had a privilege of taking the design team to Quebec, and we actually had a mock-up made of potentially the 9 by 9 meter grids with the delta beam and with the nailed laminated timber. So this actually is going to be a 12-inch deep floor slab, which is 8 inches or 6 inches of wood with 6 inches of concrete above. So linking the delta beam through the composite action with the concrete and the wood together. So very interesting project. It's got a beautiful visual, and it really is incredible to actually see a 9 by 9 meter grid done this way. Next.
And coming back to some of the initial conversations of the presentation where we're adding stories to existing building, I think that this is really one of the biggest potentials that we're going to see over the next coming years. Where maintaining an existing building and being able to densify and build on top of that to provide more housing and more kind of livable community type spaces is really important. One of the most sustainable things we can do is not kind of put all the buildings that we have currently into the waste system, and to utilize the embodied carbon that's already been placed into those buildings. But there comes a lot of challenges with topping up these buildings, in that, we want to consider the existing structural system. And so wood is a very lightweight system. It has a lot of strength compared to its weight. And so what we're seeing here is that in using wood and prefabricated kind of elements of wood in building on top has a lot of benefits. There's been a lot of case studies where the reinforcement of the existing structure was minimal, if not none, and kind of looking at spanning from structural point to structural point. The other advantage to thinking about wood in terms of densifying our building stock is the prefabricated element of a system like mass timber, and as well as a lot of lightweight frame construction has minimal disruptions to the site around it. You can imagine that the products will be made off-site. It's going to come, just in time delivery, craned into place. And so what that does is that it minimizes disruption to the community, minimizes noise, dust, the disruption in the local communities, but it also minimizes the risk of the existing building, where you can keep the roof of that existing building on as long as possible and just open it up when it's time to make that connection, if you even need to do that. So there's a lot of advantages to considering prefabricated wood structures on top of existing buildings. You want to talk to this example, Stephen?
Oh, they're just this is recent. I'm actually tracking down the case studies which will be done for the ATM in Washington DC. But again, taking that existing building stock that they had there, I think it was an existing 7-story, very large building in DC, and then they wanted to open up again, taking that philosophy of not knocking down a building just because you want to put 2 more stories on top of it, but actually utilizing the structure that's already there in place, again keeping the building away from the landfill. They went here with a prefabricated heavy timber system. I believe they used glulam and mass timber for this one. This was one of Katerra's projects before they disappeared from us, but again they utilized that method very, very quickly and efficiently in putting the 2 stories above. Next. So we wanted to provide in the case study itself a couple of illustrations of some successful projects. This is a 4-story supportive housing project that was done in Kitchener-Waterloo, utilizing cross-laminated timber really to the full extent of the expedited construction process. This was done through the RHI, the Rapid Housing Initiative that CMHC launched a couple of years ago. Really from start to finish, the team had 12 months to actually put the building up and get people actually in the building itself. So Malone Blamey Construction were the GC on the job. And it was interesting because they had a really their strength was doing precast concrete buildings. So when the team went to them and said, would you be interested in doing this, there were a lot of things around the building schedule which they were very familiar with using concrete, but not so much with cross-laminated timber and mass timber wood buildings. So part of the process at the beginning was actually telling them about how the building was going to be constructed, what the schedule was supposed to be, and how they were going to achieve that. So next. So this was the community space, communal space, where the people in the supportive housing project would come and or not. Each of the units upstairs has its own kitchenette and place where you can eat. But if you come down to the community space, beautiful illustration of a smallish type building. It's only 40 units and 4 stories, but the fact that you can actually get this lovely space that people can come, congregate, talk, etc. A really big part. This is the heart of the building itself, where people can come and talk. But on the right there gives you an idea of how the floor slabs. So they were using 40-foot floor slabs, 11 foot 6 inches wide. So each of the crane picks was very efficient. And again, this was when the costing analysis was done on the building itself. The GC was able to work out exactly how many crane picks were involved in putting each of the platforms and the floors in place. They were reducing basically the crane picks by half of what they're used to. They already have a computation in their head about exactly what each crane pick costs them. The fact that, as Veronica's mentioned a couple of times, these are light systems, so they were able to think that they were just able to use a mobile crane as well. So again, this is where the GCs, getting them involved very early in the process, can talk about costing from the buildability point of view. Next. So a great illustration of potentially how the building was going to get put together, starting off with the site work begins, the foundation work, and then the superstructure being arrived. So this is great. You can see on part number 4 there, mobile crane, the just-in-time delivery, everything being placed into place, the envelope work starting for completion of the building. And I can attest that this was such a great success. The tenants were involved or in the building in the occupied space 2 months ago or a month and a half ago. And they actually, I was by the site yesterday, they're actually starting the second building. So I always say the proof's in the pudding. And this is where now they've made a big fan with Malol Blamey, and they'll actually start using this in their projects to come. Next. So part of our work as well, Veronica and I got to tour building when it was under construction. It's amazing. You have a theoretical way of thinking about how buildings get erected. We always say it's just a giant Lego set. It's all about the planning and the work beforehand. The erection process should just be standing walls up, putting the platform frames, and then going up very efficiently. But when you actually see it happening just as it's supposed to, just as the illustration showed on the previous slide, it's actually brilliant to see it. Again, the trucks rolled into the site, so there was no blocking of the street. The mobile cranes in place, and then everything was taken off the flatbeds and actually put into the into position. Next. And what was uncanny, although the facades weren't on the building, and when we were there, they were putting the 3rd story platforms were in place. They were erecting the 3rd story walls, 4th story walls, excuse me. The roof slabs were just arriving. You can see the window cutouts from the guys on the back of the truck, but they were actually already starting to put the services through the building. So again, the pre-planning, making sure that you know where the mechanical layouts are for the building are all part of the early planning stage. And although the sides weren't on the building, there was no concrete curing. There was a very dry site. And that was uncanny. You could feel how different this was with this type of construction practice. So I don't know if you wanted to say anything from an architect's point of view, Veronica.
Well, yeah, exactly that. I think, the other thing that was observed is how quiet the site was. And, normally when you go on a construction site, as you know, it's kind of loud, there's drills, there's grinding. It's got the dampness because of the concrete curing, but this was dry, as Steve had mentioned. It was warm, you could smell the wood. But in addition to that, there was a school and a library right on the same kind of parcel of land and right across the street from this project. And it didn't seem to impact the children in the school or the people using the library at all. The kids were going out for recess. I don't even think they turned around and noticed a building was being built because how quiet it was. So I think those are really positive elements when thinking about construction, because construction for typical buildings can last, 12, 18 months. This building was built in less than 4, like the structure was up in 4 weeks. Yeah. And occupied within like 6 months, the whole building from start to finish. So pretty uncanny. It was pretty remarkable.
And the full height facade panels too that you saw on the back of the truck there. So once we were there and the roof slabs had gone on to create the roof deck, the next thing was they just came along with the crane, picked it off, and then just started vertically laying out the facade panels. Incredibly quick too, because obviously the windows were already cut out in the factory using the CNC technology. It was just a brilliant illustration of what can be done with the right kind of planning in place. So next, give you an idea of what the building looked like once the shell was in place. And I think the next slide, there is a video. So this was starting in September 1st. The slabs in place, up to towards the end of September when they started to do the ground floor walls. And by the early November, they were already putting the facades on the building itself, just in time for our first snow, which we had very late November last year. So great testament. Like I said, I was by there yesterday. So it's fully occupied, and they're actually digging the just to the left is the second site, which is going to be a 3-story, 2-bedroom version of this. So when we sort of turn our interest into supportive housing, affordable housing, and getting buildings up, which we desperately need, this may be that solution, which local communities and community services, social services need to be looking at. Next.
So when it comes to considerations when starting off a project, we have a section in there that talks a little bit about the zoning and bylaw considerations. Of course, there's the building code regulatory aspect. And then again, every town and municipality may have their own bylaw, which could impact your decision on what structural system you use and how you plan and map out your building. So this is an illustration of the Toronto Mid-Rise Guide, where there's certain kind of stipulations that may impact whether you can go 5 or 6 stories, depending on your structural system. For instance, consideration of the tall ground floor to animate the street is something that we see a lot of here, as well as stepping back the building block in order to allow for view angles and street angles. And so you want to consider how you do that step back and kind of load on your structural system, load on the mass timber system or light frame wood construction system, and kind of think about these things early in the same time that you're thinking about choosing your structural system, looking at your integration of mechanical and electrical systems as well. Really just to kind of, optimize the design and optimize the systems.
So just to sort of wrap up and bring us up to towards the end now. What we tried to do, it was a terrible time to do anything around a business case about any building. We saw an elevation of supply chain issues throughout COVID, the wackiness of not being able to get windows and doors at the right time for buildings. I've had cases where people are now building, there's a 10-story mass timber building going up in Toronto currently, and actually they purchased the windows and doors, I think, a year and a half ago, and been storing them in the basement for the build. But a big part of what we had to do was come up with something that's going to be time relevant. So whether we're looking at it now or whether we're looking at it in 5 years' time, there needs to be some relevance in it. So we tried to explore the value proposition of wood construction. And a big part of that is the expected population growth in our urban centres. I'm sure this is happening in your regions too. There's people coming in, people need to have, affordable housing that's good housing, and it's going to have longevity. So this potentially is a great fit for this. We need to be talking about carbon and sustainability goals and green construction costs, etc. The real focus, certainly right now, is about embodied and operational carbon. Veronica touched on the fact that you may be forced to be looking at net zero ready buildings. I know we're already seeing it in many jurisdictions in Ontario where they're making sure that people are looking at this. You need to have a good way of doing it that's achievable. And I think wood really does sort of tick a lot of the boxes, getting back to the research that Veronica and her team at Athabasca U have been doing as well on this particular subject. And something that's coming up very much is the environmental social governance factors, the ESG goals. You go on Bloomberg, everyone's talking about this. This is where investors, whether it's REITs, private investment as well in buildings, they're looking at, how that building is going to fit within the social and governance factors. People want to invest their money in the proper places. So we do touch on that in the guide. Next, please. So we talk a lot about the prefabrication world throughout today. This is really important. This is happening everywhere right now, and it's a thing you can't take your eye off. Components are being manufactured inside factories. Factories don't care about what the weather on site is doing. And we're training, and this is part of our work that we both do with Workforce 2030. There's a skill set which is starting to emerge from factory locations. You're becoming an assembler of parts as opposed to an erector of structural systems like carpenters typically were. We're seeing our workforce is shrinking extremely rapidly right now. So you've got to be thinking about how the building's going to be put together. So this is, we cover this extensively throughout the guide about this new approach to getting your buildings put up. So big factor in this as well. I'm sure this is happening everywhere. Dumping fees are escalating. You want to reduce as much in-site waste as possible. And again, having a system that's already built, delivered to site, and there could be everything from closed panels to modular to open panel work, which many of the truss fabricators are able to do. It creates the rapid building and gets the efficiencies doing, but you have to put your homework in at the beginning. The building schedule, again, reduction of that erection time has a huge consequence on actually the success of the business case. There's a massive saving there, but you have to understand all the parts. And I think we've highlighted it very well in the guide. Next, please. Insurance, a big part of wood buildings. There's always conversations which I get, and I'm sure that the team at Maritime Lumber Bureau as well and Woodworks program can talk about insurance costs. Course of construction insurance, we cover it very well inside the guide in a couple of different places, and the importance of making sure you've got the right broker. They understand your approach to building with wood, how you're going to deliver the constructability and the impact of the reduced construction time is going to have on your premium. A lot of work as well about the warranties. Lots of factors affect the warranties to make sure that if you've been told by the course of construction insurance provider to provide site security, make sure you do it, because you don't want to void your warranty. So we have quite a comprehensive from a great insurance person, Connie Rowley, that talks about some of these issues around warranties and making sure that you've got risk controls actually in place on the site. Section 5.8 inside the guide specifically deals with site conditions, risks that you may be coming up against on the construction site, and establishing a fire safety plan and a safe work plan. And there's a whole heap of information and resources and references that you can go on and actually find out how this can be done. We've illustrated enough during in the guide itself, but if you need more information on it, please feel free to reach out. Next. So the technical section overview. Next. Some of the work that we deal with is really about how you actually design the building from an engineering fire safety point of view as well. I always say that the biggest thing is communication between the professionals, making sure that you stitch teams together. This is not just the client with the architect, this is the architect, the structural engineer, the fire code consultant. Everyone needs to be around the table. We've got some great illustrations on how that can be done. You've got to be thinking about the structural design. Veronica may have an image of a building in her head. She needs to have a team from the structural engineering perspective that can actually deliver that. So we talk about the importance of the layouts of the units, the grid spacing when it comes to office buildings. If you're bringing in the mixed occupancy caveats as well, you can understand how it's transferred down through the building. Mechanical systems, you know, one of the areas that I don't think there was enough focus on. You have to understand, you know, how the building's going to breathe and behave once the systems are all in place. So again, getting back to how I'm going to lay this out, where's the ductwork going to be going? How is it going to breathe once it's occupied? And this all bears down with the architectural considerations, the load-bearing wall placement, the openings, the acoustics, and whether that can be delivered using off-site prefabrication and the proper planning. So next. So the structural design section as well, we brought in the National Building Code 2020 provisions. So it's as up to date as we possibly could have had it. Obviously, there's always a a line which we have to draw and say, okay, that's it, we have to go to print now. But the idea, again, this illustration is from the Seco Bois project, which we then used and then updated. But again, it's that alignment of the shear walls through the structure, making sure there's great alignment within a residential building or an office building to transfer the load through. Next. So getting back to some of the issues with wood buildings, depending on what your structural system is, the shrinkage calculation that a structural engineer that's well versed in wood construction and wood design will bring in was the shrinkage factor. So understanding exactly how the structural system itself is going to transfer the gravity loads and the operational loads throughout the building. And we give some really good illustrations in tables about the types of construction materials you're going to use, what the moisture content is, how that's going to affect the building once it's in situ and it develops the moisture content, which is typically about 6%. We don't want dry buildings because everything's going to crack. So majority of buildings, there is moisture in them, which is about 6%. So you've got to understand the moisture content of the materials when they're delivered to the site after manufacturing, how they're going to take on the site conditions, etc., and protection of that throughout. Next. We talk about some of the connections that you're going to see with higher wood buildings. Some of the conventional ways of tying floors, tying walls and floors together through a 4-story don't have the capacity when you're into 5- and 6-story buildings. So you've got tie rod systems. So we extensively go through with Robert Koch, who drew up the structural section as well. Placement, you can see on the left there, this is a tie rod system, obviously showing the tension and compression which you might see inside a wood building because it's ductile, but also the location of that in a concrete slab. So again, you've got to know how you're going to construct the building because these can't be put in after. So placement of this and the locations are critically important at the beginning. And we talk about how the panels themselves, whether it's light framing materials or CLT systems, are actually connected. Next. The fire safety section, I think the illustration in this section is second to none. We talk about how particular assemblies, concentrating here on the floor assemblies, are put together, where you're required to have insulation bats, how a ceiling is put into place to keep the continuity of the 1-hour fire separation that's required inside a unit. I actually had a technical question on this late last week from a colleague of mine, and the information is actually in the guide. So the continuity of those fire separations are critical in the building operation. You don't want partition walls to interfere with the gypsum wallboard assemblies that may be on the floor systems, etc., to create that 1-hour fire separation. So lots of really interesting work inside the in the guide for that. Next. And we like to finish with this slide. The guide itself was printed and in circulation. We were doing our little speaking tour on it, and ThinkWood had actually put out this forecast for 2022 to talk about the top 5 trends which they were seeing across North America for buildings for the future. I like to think that we've covered quite comprehensively low carbon construction, affordable housing and the need for it, prefabrication and modular construction, the use of mass timber, and the use of hybrid construction, where we're mixing concrete, steel and wood together for the future of our buildings. So that was a great little thing that we saw, Veronica, right? With knowing that we were on the right path for everything. Things that were affecting certainly clients and their design teams, the influence of architecture, structural engineering as well, to make those 5 things a reality. So good. So Vinny, I think that's about it for us.